There is a mystery that haunts every astronomer, every physicist, every thinker who has ever looked up at the night sky. It's a question that gets deeper and more profound the more we learn. The facts are these. Our galaxy, the Milky Way, contains up to 400 billion stars. We now know, thanks to telescopes like Kepler and the JWST, that most of those stars have planets. A conservative estimate suggests there are at least 20 billion Earth-like, potentially habitable planets in our galaxy alone. 20 billion. Our universe has been around for 13.8 billion years. Our own solar system is a relative newcomer, at just 4.5 billion years old. That's plenty of time for other civilizations to have arisen on other worlds, billions of years before us. Time enough to master technology, to cure disease, to spread across their solar systems, and eventually across the stars. And yet, when we point our radio telescopes to the sky and listen, we hear nothing. A profound, deafening cosmic silence. So the question isn't, are we alone? The question, first famously asked by the physicist Enrico Fermi, is, if we aren't alone, where is everybody? This is the mystery of the Great Silence, and it is perhaps the most important unsolved case in all of science. In any investigation, when the evidence makes no sense, you have to look for what you're missing. In the case of the silent universe, astronomers have a prime suspect. A concept so powerful and so terrifying, it's called the Great Filter. The truly terrifying part is figuring out where that filter is. Is it in our distant past, meaning we're special? Or is it waiting for us, just around the corner? We'll investigate that chilling possibility in just a moment. The Great Filter theory, proposed by economist Robin Hanson, is simple. Imagine the evolution of life as an impossibly difficult obstacle course. To get from a dead planet to a galaxy-spanning civilization, you have to successfully pass a whole series of hurdles, or filters. The Great Filter is a wall so high, a barrier so impossibly difficult to overcome, that almost no one, or perhaps absolutely no one, ever makes it past. To understand the odds, consider the famous Drake equation. It's a formula that multiplies the probabilities of all the things needed for a communicative alien civilization to exist. Things like the rate of star formation, the fraction of those stars with planets, the number of those planets that can support life, the fraction of those that actually develop life, and so on. While we don't know the exact values, the equation shows that the potential for life is enormous. The fact that we see none of it means something is stopping it. Something is filtering them out. The entire investigation now hinges on one critical question. Where on this cosmic obstacle course is the Great Filter? Is it in our distant past, or is it waiting for us in our future? The answer determines whether we are the first or the last. Let's investigate scenario A. The filter is behind us. This is the optimistic, hopeful scenario. It means we are incredibly, ridiculously special. It suggests that one of the steps we've already taken was the Great Filter. Perhaps the leap from non-living chemicals to the very first simple cell, a process called abiogenesis, is so fantastically rare that it's only happened once in this entire galaxy. Or maybe the filter was the jump from a simple prokaryotic cell to a complex eukaryotic one, with a nucleus and mitochondria, the engine of all complex life. If this is true, it means we've already passed the hardest test. The empty cosmos is not a graveyard, it's a cradle, a cosmic frontier waiting for us. We are simply the first. But then there's scenario B. The filter is ahead of us. This is the dark, terrifying alternative. It suggests that the path we've walked is actually easy, and that many civilizations have come this far before. The silence of the universe, in this scenario, is a warning. It means there is a wall waiting for all intelligent life, and no one has ever survived it. This filter would be a challenge that all technologically advanced civilizations eventually face, and all of them fail. What could it be? The invention of technology that inevitably leads to self-destruction is a prime candidate. Nuclear weapons, uncontrolled artificial intelligence, a planetary-scale environmental collapse. The filter could be the very intelligence that makes a species successful in the first place. Or maybe it's an external, predictable cosmic event, like a gamma-ray burst, that regularly sterilizes life before it can become interstellar. If this is true, then the silence is a graveyard. And we are just the next in a long line, walking right towards a test that every single civilization has failed so far. It's a sobering thought, and if you're still here pondering it with me, let me know by commenting with #SilentUniverse. But what if the great filter isn't the answer? A good detective considers all possibilities. Perhaps the universe isn't empty, it's just hiding. This leads to the chilling dark forest theory, popularized by author Cixin Liu. In this scenario, the universe is like a dark forest at night. Every civilization is a hidden hunter, trying to survive. You stay silent, you don't light a fire, because to reveal your location is to invite your own destruction by another hunter who is older, more advanced, and more paranoid. In this universe, the only winning move is not to play. Or maybe it's the zoo hypothesis, that we are an exhibit, a cosmic nature preserve, deliberately left alone and observed by intelligences so far beyond us that we can't even perceive the bars of our cage. The truth is, we don't know the answer. We are detectives at a cosmic crime scene with no witnesses. The great silence could be a promise of a universe that is ours for the taking, or it could be a warning of a fate we are destined to meet. The only thing we can do is keep investigating, keep listening, and act with the wisdom that either possibility demands. If this mystery fascinates you as much as it does me, subscribe and join our investigation into the cosmos. There are many more clues to uncover,